Hi, this is Umberto from NerdKit. Recently, one of our customers in Texas emailed us about an interesting project he was doing. He owns a bar. Basically, he wanted to weigh a new shipment and, based on the weight, determine how many bottles there were, and then have the NerdKit automatically update that inventory on his computer. We thought having a scale hooked up to a computer was a really cool idea, so we decided to try it ourselves. We went to Target and bought a $20 digital scale. The model we bought was a Taylor electronic scale. Now Mike is going to explain how these digital scales work.
We need to figure out how to measure force electronically. First, we have to realize that whenever you push or pull on a material, it stretches or gets compressed. Mechanical engineers call this stress and strain. So, imagine a diving board. If we put a weight at the end, the tip moves, the top surface gets stretched, and the bottom surface gets compressed. Now imagine a resistor. Like we talked about in the NerdKit's guide, resistors are a common circuit element, and even a wire is a resistor. So, just like a pump has to work harder to push water through a longer and narrower pipe, if we stretch that piece of wire and make it longer and narrower, its resistance will go up. If that wire is sitting on top of the diving board, also known as a cantilever, then by measuring its resistance, we can figure out how much force is being applied at the tip. That's the basic idea behind a strain gauge.
So let's take a look inside the scale. On the bottom part, you'll see all the electronics. The sensor itself has the 4 wires coming off the bar in the middle of this picture. The V-shaped part from the top pushes on the end of this beam, which is just like the diving board we were talking about earlier. The sensor wires go into the circuit board, and they're labeled S+, E+, S-, and E-. It's a pretty good guess that S and E mean sense and excite.
So if it's just a resistor changing as it's being stretched, why are there 4 wires? This is actually a setup with 4 resistors, called a Wheatstone bridge. It's used because it makes it possible to measure very small changes in one of the resistances, like we have in a strain gauge. So by having these 2 wires drive an excitation voltage, and just measuring the voltage difference on these 2 sense wires, we can turn a tiny change in resistance into a voltage difference. In fact, for the scale, the total voltage difference is just a few millivolts when a person's full weight is applied. This signal is way too small, so we need to amplify it.
We decided to use a chip from Analog Devices called the AD620. This can amplify a very small differential voltage, and we set it up to amplify by 150.
So we can hook up the amplifier like this to amplify the signal before it goes into the microcontroller.
Here's how everything's laid out on the NerdKit's breadboard. We basically built the normal NerdKit, and then just added the amplifier. There are 4 wires heading off the bottom of this picture, which go right to the sensor. The white and blue wires are the sense wires. The black and red are the excitation voltage.
The code we wrote takes a stream of values and builds a graph of the weight on the scale over time. We also created a different app that just divides the value in pounds by the weight of 1 can, so we can see how many cans are on the scale.